Okay, so in this section, like I was saying, and before, I wanted to calculate that ratio so I can get my even spread of particles. So the way to go about doing that is by quickly sort of jumping into sobs. So let's lay down a new sob network, and what I will be doing as well, is generally a good habit, is just adding a little null, and over there I'm just going to say to sobs. So I know this node will go back into sobs. It's not an out node, so it's not a final node, but it'll be good to kind of reference it later on in sobs. So let's jump inside of sobs. So at the moment, if you can see of my path, I'm in objects, geo1, inside of a popnet, and inside of that popnet I just lay down a new subnet. What I'm going to do is I'm going to merge my particles. Oops, not a new network, but a pop merge. There we go. And the pop path, if I just go and find it, right, is to sobs. That's the one that I'm looking for, right, to sobs, and accept this. Okay, so as you can see over there, there's some particles over there. One of the things that I need to do now is use a sob expression. The reason why I'm using a sob expression and why I do this entire sort of subnet, laying it down, is because if I bring up my HScript text port and my xhelp, if you just type xhelp, then the one that I want to use is point. So if I type xhelp, point list, if I type this, then the problem is you need to input a sob. So I would not be able to just use this expression inside of pops, and basically it would just it wouldn't work. It would expect a sob. The expression would not evaluate. It wouldn't recognize this thing. So basically that's why I lay down a pop network, so I can start using a sob network, so I can start using this expression. Okay. So over there I want to create a new attribute. Create. The attribute I want to create is going to be num points. So the number of points that are currently inside of the split group. So the way to go about doing that is basically I need an integer. So it's not going to be a floating point, it's going to be an integer. I want to make this visible. The value is going to be an expression. So the expression that I was typing earlier is going to be point list. This will give me a list of all the points inside of a certain group. That's quite convenient, because normally if I query, say, the points that are inside of the split group, right? At the moment, for instance, there probably isn't there is a split group, but there's nothing inside. It's a 0 point in split group. It's only when I go to frame 20. So if I just go to frame 20, there we go. Then we can say we've got 27 points in split group. It's that number, those 27, that I finally want to get out of there. So the way to go about doing that is using a point list, but on top of that, since this will just return me a string containing all the points in the point group specified, so basically it's gonna return 0 space 1 space 2 space 3 space and so on till it listed all those points. I'm going to put another expression around that, which will be the argc. So if I just say xhelp argc, you can see what that does. So this will basically input a line and count the arguments of this thing. So for instance, argc, this has 4 arguments. This will basically return 4. So in my case I would get point 0 space 1 space 2 space 3, but basically that argument inside is basically a string, right? And the return value will be an integer. So that's what I will be using to kind of get to that maximum number of points. So let's type this first in, point list. Okay, the node that I want to reference, is gonna be above this, and it's going to be pop1. Since pop1 on its own is referencing that to sobs. Okay, a little error because my expression isn't finished yet. So the group that I want to sort of reference is going to be split underscore grp. So all the particles that are inside of the split group. Now this will basically again error out because this is a is a string that it returns. So what I need to do, argc, I need to count those all the arguments inside of that. Okay. Now let's have a look. this should work now. So let's have a look. There are, might have to rewind this. Let's have a look. Yeah. So I rewind my particle system, and now it's fine. So if I just get it up to 20 again, there we go. Yeah. You can see at the moment the value is 27, which is good. That's what I wanted. So 27 points in split group. There we go. Yeah, so it's that number. It's now in there. And the only thing I need to do is I'm going to add a little null, and I'm going to say back 2 pops. Yeah? So this will be kind of easy for me to get to that value. And I'm going to name this guy quickly, this attribute create, so that I know num points. You know, this attribute num points, which is a point, which is of the type integer. This is very important because we're going to be using it later on in VOPs, and this type needs to be correct. Okay. Now we're going to go back up. So that attribute is sort of being calculated inside of there. So how do we get it onto our particles? Well, besides of creating a new attribute, we can do an attribute transfer. And that's what we're going to do now. So underneath this, so you can kind of see this as almost a separation, sort of, you know, like subnet, and the stuff we do inside of my subnet is num points. So num points, and that's basically the function of that subnet. Then the attribute transfer, and from there we're gonna continue on calculating. So attribute transfer, what I want to transfer is the num points. So if I get this guy, then okay, the source group of my attribute transfer will be the split. So the split group over there. The sub that I want to reference is the one inside of my num points. So the one inside there. So I'm going to get to it. So this guy, 2 pops. Accept that. Now the attribute that I need to transfer is going to be my num points. So it just fell out of the screen a bit, but there it is, num points. Okay. Now if I bring up my spreadsheet, I'm just going to rewind this and bring up my spreadsheet, and you see the frame at the moment is 24. But because that only is assigned to split group, and split group is not preserved, which means it's only going to be assigned once they are being born, when they are born. So you can kind of see the num points is only going to be stored in the current split group, so not at each frame. So you can kind of see the first group is, you know, like there's 27 sort of particles in that split group. If I play this a bit further, okay, the second group, so you can kind of see there is 30 particles, so that's sort of the maximum that it can kind of reach for. Okay, the next thing we want to calculate is the index. Now, before we can do that, before we can start calculating that index, we need to be able to, you know, use that num points. So a little quick thing that I need to do is sort of add an attribute to it. So I'm going to create an attribute in there. And whereas I've transferred it there, there's a little problem which seems to have occurred, which does not allow me to query my num points straight away inside of any kind of calculations. So what I'm going to do there is just attribute, I'm going to call this one num points. Real easy, I'm going to call this num points. Yeah. The local variable as well, num points, is going to have to be an integer. And in the value, I'm going to put in $num points. What that means, oops, num points, yeah, there it is. What that means is that in the beginning, when there is no split group, this is also being applied to everything. When there is, you know, like basically when there are no particles being split off, that means that there will already be a num points attribute for the first particle, which is 0. Otherwise, it would just jump and create a new attribute as soon as there's particles being split off. Now the advantage is that the incoming num point value, that's already there, is going to be applied to this new num points value. And the nice thing about that is this $num points is actually self-referential, which means that it will get the value of this num points, but since it has an incoming value, it will sort of overwrite itself. Well, basically, the only reason why I did that is because now I can kind of access whatever I need to do through this $num points. Okay. Now I need to calculate an index, so I'm going to add another new attribute. This is going to be an integer. Yeah, and I'm going to call this pt index. And again, there as well, attribute pt index. There. Alright, so this is going to be a little formula. Yeah, so we're going to start off by using the point number. Yeah, and I'm going to subtract from this point number the total number of points. The total number of points minus the justly, the number of points that I calculated, which are, so basically the number of points that's currently in the split group. So $num points. So num points. Oh, come on. Points. There we go. Right. Make sure that it's an integer. And the other thing as well is that we kind of want to apply that to our split group. Okay. Let's have a look in the spreadsheet what this will do. So play this thing, and you can see the particles are still, flying off. And if I bring up the spreadsheet, yeah, then you can see, okay, now we've got our point index, which goes 0, 1, 2, 3, 4, 5, and so on, all the way to 27. I know this because, I stored my maximum number of points. And the other one underneath is 30, but again, it starts at 0, 0, 1, 2, 3. And you can kind of see the last one of the previous thing is 26 out of 27. Yeah? If it would go to 27, then it would basically be the same as 0 out of 27. Yeah? So it does do a full sort of cycle through those numbers. Yeah? And this one will go to 29 there, and then the next one will go to 28. Yeah? And so on. So now I've got this index, yeah? And this index can be used inside of my my VOPOP to kind of calculate that spread. Okay, so let's dive inside of there, and let's bring in those attributes. Yeah? So I'm going to create two new parameters. The first parameter will be my point index, so pt index. I don't want floats, I want integers, and I need to make sure that my naming is correct, so pt index, pt index for the label, that's fine. I'm going to create these parameters, rather also this guy, this velocity, as invisible parameters, so because at the moment, as you can see, it starts to pile up in there, and I don't really want anybody to mess with them. So if I make them invisible, they won't be able to change them. So the velocity invisible, gone. The point index invisible, so that's gone. So if I just go up, they're not there anymore. Yeah, so that's good. So I've got the point index. The other thing that I want is the number of points, so the maximum number of points that are currently in that split group. So let's call this one num points. Yeah. And I'm going to grab this guy again, paste it there, make it into an integer, make it invisible as well. Okay, so now what I want to do is I want to make sure that I kind of calculate this ratio. So in a way, just like the random gave me a number between 0 and 1, I want a returning value, a ratio between 0 and 1. And then one good expression to use is the fit. Yeah? So I'm going to fit these values, so I know that this is the current value and this is the maximum value. So I can kind of remap them, say instead of going from source being 0 and the maximum being 1, it's going to be the source value being 0, that's fine. The maximum is however going to be the number of points. Yeah? And the destination minimum 0 and the destination maximum 1 is fine. And those values will then be plugged into the same kind of, into the multiply constant and go through the same remaining calculations. However, the problem is these are integers, these are floats, so I need to make sure that this corresponds. So what I'm going to do is convert integer to float. Yeah. So this guy is going to be converted. Yeah. So now this is a floating value. This is the current value. So I'm going to plug this into the value, copy this, paste it. Just make sure that this num points is also converted to a float, and put it into the maximum, so the source, the maximum of the source. Okay, and then I've got this value. Yeah, so this is now returning a value because I left it at default between 0 and 1. Wouldn't it be nice if we've got a little control to say like, okay, I want to switch between either a random, so a random value, or I want to have this kind of nicely spread out result. So what I'm going to do is just move this over a little bit, put in a switch, and I'm gonna add a little bit of control for the user. So just say either I want this random value or I want this guy. So in the switch, first of all, I need to create a parameter which will allow me to control the switch. We'll say 0 or 1. 0 or 1, well, that's going to be a toggle. Yeah, so a randomization toggle. So if I say toggle there, I can say switcher, and let's call this random just to make sure. Switcher random. The label, since I do want to use this one, I want to provide this one. I'm not going to make it invisible, so I'm just going to say, let's call it switch random, which basically means that if this guy is switched on, so if this value is 1, then it's going to have to be random. So in the first input, I'm going to plug in my resulting ratio over there. Yeah? And in the second input, I'm going to plug in my random. Yeah? If at any moment you want to check some of these values, you can just lay down a new print. So there we go, a new print, like this. And you can output this to the text console. So at this point you can kind of start to see, if you wanted to, like what that does. Poof. So I'm just going to show this is the result of my console. So what do we get? We get our shift values. We go from 0, 0, 0, sort of 0.1, 1, 1, 0.2, 0.3, 0.4, 5, 6, 7, 8, and 9, sort of to the maximum value of 9. So that's good. I don't need this print anymore, just as a check, just it's like a debugging tool. Okay, so I've got my switch there. Then the result of this, we'll need to go into that multiplication value, because both of them go from 0 to 1. So I'm going to plug this one into my multiply, and everything else is fine. Everything else will sort of continue on working. So if I go up, at the moment my random is not switched on, which basically means it should do the even distribution. So there we go. Yeah. So nicely even spread out circles. Yeah. And there we go. Yeah. With random numbers, of course. So there's not an equal amount of particles in each split group. Yeah, so that's quite good. One thing that we might want to add now is sort of tangent velocity. So like I mentioned before, since I sort of added those vectors, those velocity normal information on top of every point, I can start to use that with my tangent velocity. And that's for the next section. So let's save it.